get started. All right, so we're going to review first just the forms of a quadratic function. You definitely want to write these down. Math Excel and your book are going to be very specific with the names of the forms. So we're going to start with this form, which is the one that we use when we have like our quadratic formula, or if we want to solve a quadratic by factoring. F of x equals ax squared plus bx plus c. Our textbook calls this general form. Okay. We also have this form of a quadratic, which our book calls standard form. In the past, when you guys have done these, you probably called the top one standard form and the bottom one vertex form. Our book uses different names, so you're going to have to be careful with that. You might hear me still say vertex form for that bottom one just because it's a nice, easy way to remember it. But general form for the top, quadratic standard form for the bottom. Quadratics are anything that has a degree of 2, highest power of a 2. So we'll have an x squared term, an x term, and a constant term that will create that general form. And then if we factor it, we get that standard form. The standard form is nice, especially when we're naming properties of the quadratic, because we can find various things from the values within the equation. The vertex of the quadratic, which we know it makes a parabola shape, that U shape. The vertex is either the highest point or the lowest point. That's going to be H and K in that standard form. Also, we're going to have an axis. Sometimes it's called an axis of symmetry. That is going to be X equals H. The X equals there is really important because it's a vertical line. It's going to be a vertical line that goes right down the middle of your parabola. So that's what makes it symmetric on either side. If you were to perform a reflection, the parabola would look the same. Then, if A is greater than 0, and it doesn't matter what form your equation in, A is going to be the same number either way you look at it. It's going to be whatever's in front of that x squared. If A is greater than 0, if A is positive, your parabola is going to look like this. It's going to, what we say, opens up. And then that means the vertex is going to be at the bottom. So we say that the graph has a minimum value. If A is less than 0, the parabola is going to open down. And that means the vertex is at the top. So we say the quadratic has a maximum value. And again, if you wanted to draw in the line of symmetry, it would look something like that. X equals H. That H is the same H that's in the first part of your vertex because the line of symmetry always goes through your vertex. It's a vertical line through your vertex. All right, so I'll give you a minute to write all of these little pieces and parts down, and then we'll do some problems with quadratics. Everybody have what they need here? All right. Let's try this one. We're going to do this one together, and then you can try one on your big idea worksheet in a minute that looks like it. So it says, find the standard form of the quadratic function f, whose graph has a vertex at 1, -5, and passes through the point 3, 7. And then after we find the equation, we're going to answer, does this function f have a minimum or a maximum? All right, so I'm going to start by just writing down my standard form. Again, here, that's f of x. It's our vertex form. Equals a x minus h squared plus k. This is going to be similar to a few things we do when we find an equation in y equals mx plus b form, a linear equation. Our goal is to find every value in this equation except for x and y, which is our f of x there. So we need to find a number for a number for h, and a number for k. If I can do all of those things, I will have a complete quadratic equation. Do I have any of those values now? A, h, or k?
H is 1.
Good. H is 1. Anything else?
K.
Yeah, if you have the vertex 1, -5, you have h and k. So we're just going to plug those in. F of x equals a, x minus 1 squared, and then you could say plus -5. I'm just going to say -5. So the only thing I'm missing now is a. If I can find a, I'm done. Again, it's kind of like what we do with the line, y equals mx plus b. Once you have the slope, what's the next thing you do to find the y-intercept, usually? To solve for b, what did we do? Do you remember with lines? Yeah, you plug in a point. You plug in an x and a y value, and then in this case, a will be the only thing left, so we can solve for it. And that's that other piece of information really that we haven't used yet. We have this other point on the line. It's an x and a y. Plug it in. My y is 7. My x is 3. And a is the only guy left. So let's solve for it. Order of operations says do the parentheses and square it first. So 3 minus 1 gives me 2 squared. So there's going to be a 4 multiplied by that a. Then what? Add 5. 12 equals 4a. So a is 3. All right. I have a. I have h. I have k. That's enough to write a complete equation. My final function f is going to look like 3, my a, x minus h1 squared plus -5 or -5 in for my k. Okay, so what else can we answer about this question? Can you tell me, does it open up or down? Fletcher did this. That is the international symbol for up. It opens up. How do you know? Because a is a positive number. Oh, come on. There it goes. All right, a is positive, so we know it opens up. What else? If it opens up, what else can we say about the vertex? It's a minimum. Picture a parabola opening up. The vertex is going to be right in the center of it. It's at the bottom, so we have a minimum. Can you tell me, it doesn't ask for it here, but can you tell me the domain of this function? We just did it on our test, right? Think about domain restrictions. Would this function have any domain restrictions? Denominators, square roots. So the domain is all real numbers. What about the range? We're not going to find an inverse. We're not going to make it that hard. We almost have a little sketch of it, right? We know it opens up, and we know the lowest point is the vertex, 1, -5. So what's the range going to be? My y values. -5 with a bracket to infinity. The lowest this graph goes is the y value, -5, and it's going to go up forever. Your range for these graphs will always be either everything above the vertex if it opens up, or everything below the vertex if it opens down. And your domain will always be all real numbers. These are not going to have a variable in the denominator. They're not going to have a square root, so the domain is always all real numbers. So those are usually pretty easy to get. We don't have to worry about doing inverses and making it complicated. All right, I want you guys to try the one on your paper now. Big ideas. Number 2. So I want you to find the equation. I also want you to tell me which way it opens, min or max, domain, and range. Let's get all of those things up there. All right, I'll give you a couple minutes. Thank you. Work with your group. Put these up here. Did you get A is -1/9? We'll give that exact answer. So because that's negative, it opens down. Because it opens down, you have a maximum. Domain is always all real numbers. And then because it opens down, your maximum y value is at 6. Your range is -infinity all the way up to 6. Everything below 6, including that vertex 6. What questions do you have on this? Anything? We're okay? All right, moving on. Do you remember from when we did circles a couple months ago, completing the square, halving it, squaring it? Does that sound familiar? Where you're factoring, halving it, squaring it, adding it to both sides. Okay, I put the steps on here in case you want to refer back to them. They'll be on Polaris. These are the same steps we saw a couple chapters ago with the circles. We're going to practice them with quadratics, okay? The good news is with quadratics, it should actually be a little bit easier than what we did with circles, because instead of completing the square with both my x and your y, you only have to do it with the x's. All right, and I will number the steps on here the same as what those steps on the previous slide say. So again, in case you need to refer back or you want to see each step individually, it'll be there for you. All right, so we're going to do one example where there's not anything in front of the x squared, and then we're going to do another example where there is something in front of the x squared, and then you guys will have an opportunity to practice. All right, to complete the square, and the goal of this is to get something in general form, the A, B, C form, into standard form, the AHK form. Because if I can get it to look like that, I can name the vertex really easily. First step is whatever your C value is, you're going to move it to the other side. That's 2 in this case. I'm just going to subtract 2. Second step says, if there's a number in front of the x squared, we're going to factor it out. Do I have a number in front of the x squared in this problem? Other than 1? No. So second step, we just skip if there's nothing in front of my x squared. Third step is our half it, square it step. And I'm going to leave a little room because I'm going to add something to both sides here to keep my equation balanced. To find out what we're going to add to both sides, you're looking at your linear term, your x term. So that's -2. If I take half of -2, what do I get? -1, square it, +1. We're going to add +1 to both sides of my equation. That keeps it balanced. Again, that's half it, square it. That's where that's coming from. Fourth step, we're just going to simplify each side. On the left side, -2 and 1 give me a -1. On the right side, you should be able to factor this now. We've created that special case of factoring where you should be able to find the same parentheses twice, where your terms multiply to the last and add to the middle. What in this case multiplies to +1 and adds to -2? What two numbers, or what number twice are we looking for? -1 and -1. So you could write y - 1, y - 1, but remember we want the condensed form, or not y, sorry, x. We want the condensed form, so we're going to say x - 1 quantity squared, which means that parentheses times itself. Okay. Last step, just get the y by itself. Move that 1 back over. Final answer is x - 1 squared plus 1. Can you tell me the vertex of this parabola now? What's the H? 1. What's the K? 1. That minus inside the parentheses is built into the formula. Remember, the formula was x minus h, which means if you have the equation and you're trying to find the x coordinate, they should always be opposite signs. If you see a minus in here, it's a positive x coordinate. If you see a positive in here, it's a negative x coordinate. Your y coordinate will be exactly the same. It's the plus in the formula there. But that negative in the formula tells us use the opposite number when you're finding that vertex for the x coordinate. Okay. Let's try one more together on the right there. We're going to follow the same 5 steps. Step number 1, we're going to move the constant term to the other side. So I'm going to say y plus 11 equals negative 3x squared plus 18x. Step 2 says if you have a number in front of the x squared, factor it out, which we do in this problem. I have a negative 3 in front of the x squared, so we're going to factor it out, kind of like we did with our parent functions. Now, could I factor an x out also? Technically, is that a common factor on the right? Yes, I could, but I don't want to. I want to make sure that this stays a quadratic, that it continues to be an x squared so I can factor it later. So although you could take an x out, don't do that, just the number in front of the x squared. So that leaves me with what if I divide both of those terms by negative 3? X squared minus 6x. All right, so that's all you have to do for the second step. Third step, we're going to complete the square. We're going to half it square it. So I'm going to leave a little room on each side. Y plus 11 equals negative 3x squared minus 6x. And when we complete the square this time, the number we're going to add in is going to go inside the parentheses. We are still looking at the x term to half and square it. That's the number that we're using. So negative 6. Half of it is negative 3, square it, 9, plus 9. Okay? What do I add to the other side to balance that out? Hint, the answer is not 9. It is negative 27. Where does that come from? Yeah, when I put something inside the parentheses, even though it looks like I'm adding a 9, that 9 is multiplied by negative 3, right? Everything inside that parentheses is multiplied by what's out front. So if you factored a number out, you have to kind of take that into consideration. We're not adding the same number to each side. We're adding the same amount to each side. So really, I added a negative 27 over there. So I'm going to add a negative 27, or you could just say minus 27 on the left. All right, simplify. On the left, I'm going to have y minus 16. On the right, we can factor our x terms. What number am I looking for if it multiplies to 9 and adds to negative 6? Negative 3. So you could say x minus 3, or we're going to write x minus 3 squared. We're just condensing that trinomial. Last step, get the y alone. Y equals negative 3, x minus 3 squared plus 16. What's my vertex? Positive 3, positive 16. There are 2 ways that you can check these answers. Option number 1, to go from standard form back to general form, all you have to do is FOIL and combine your like terms. So you guys can do that pretty easily. You do not need a graphing calculator or any calculator more than likely to do that. You just FOIL it out, take it back where it started. If you have a graphing calculator, it's even easier. These 2 equations, what we started with and what we ended up with, are the same parabola, right? It's just a different form of the same equation. So in your calculator, you can graph both of them. You can graph them at the same time. And if you did it right, what should it look like? 1 parabola. If you did it wrong, you're going to see 2 different parabolas. So that's a quick way to do it, especially like with Math Excel, if you want to check it before you type it in. Graph your equation that you started with, graph your answer, make sure it's the same picture. Okay? All right, you got one on your big idea worksheet that I want you guys to try. Looks like this. So this one says convert it to standard form. So you're going to complete the square, name the vertex, then tell me which way it opens, min or max, and you know what? Let's go ahead and throw the domain and range on there one more time, just for a little extra practice. Why not? All right, let's take a look at it. So I subtracted 9, and I factored out the 2, which leaves me with a negative 4 in front of my x. Then I take that negative 4, half it, square it. Half of it, negative 2, square it, 4. 2 times 4 gives me a positive 8 that I'm adding to the other side. Same amount on both sides. Then x squared minus 4x plus 4 factors to x minus 2, or x minus 2 squared. Negative 9 and 8 give me negative 1. When I move the 1 over, it becomes positive. That gives me this final equation. Vertex then to 1. Because my a is a positive number in front of the parentheses there, it opens up, which means I have a minimum. Domain is always all real numbers, and the range would be my minimum value up forever, which my minimum value is the y-coordinate of my vertex 1 to infinity. Okay? What questions do you have here? Anything? Okay, I've just got one more slide for you, then we're done for today. There is a shortcut to finding the vertex if you don't have to find the whole equation. Let's say you have this general form and all you want is the vertex. You can use this formula, and actually you don't even need the whole thing. I would just worry about the negative b over 2a. That gives you h. If you want the x coordinate of the vertex, or h, you do negative b over 2a, and a lot of times we say opposite of b over 2a. The reason we don't really worry about the second half of this formula is once you have the x coordinate of any point, to get the y coordinate, you just plug it in, right? That's all that really is saying. F of negative b over 2a means take your x coordinate and plug it into the function to get the y coordinate that goes with it. All right, so let's try it with this function at the bottom here. I've got f of x equals negative 4x squared plus 12x plus 7. To get h, or the x coordinate of my vertex, opposite of b over 2a. What's the opposite of b in this problem?
Negative 12.
Negative 12 over 2 times negative 4, which will give me negative 12 over negative 8, which is 1.5. Can you think of anywhere else where we've used opposite of b in the numerator and 2a in the denominator? This comes from the quadratic formula. Okay, that's these kind of overlap a little bit when you're solving for zeros of a function, roots of a function. So if you remember that it's the first kind of pieces in the numerator and denominator in your quadratic formula, you know that already, so you really kind of know this already. Once you have the x, you just plug it in to get the y. So negative 4 times 1.5 squared plus 12 times 1.5 plus 7. And then you can use your calculator. Even basic calculator would work here. You get 16 for that one. So my vertex is 1.5, 16. So that saves us from all that work of completing the square if all you need is the vertex. Now, other questions is asking at the top here. Does it open up or down? Down. Vertex we already have. Does it have a min or a max? If it opens down, it has a maximum. The other thing it wants is the axis of symmetry, line of symmetry. The line of symmetry will always go through what? The vertex. And it's always what kind of line? It's a vertical line. So vertical lines always start with what? X equals. And if it's got to go through that point, what does it equal? 1.5. Here's another awesome thing about this formula. Let's say you get totally stuck on completing the square, you're getting it wrong every time, or it's just a test and you forget the steps. Once you have the vertex, that's your h and your k, right? Do we know what a is? What's a? Aren't those the three things that I need to write an equation in standard form? I can kind of roundabout skip completing the square if I do this. I can say this function is -4 x minus 1.5 squared plus 16. I just have to plug in my a, h, and k once I found it using this instead. Okay? So that's kind of nice if you get stuck or you want to check your answer or you just don't want to complete the square. And we will stop there for today. Okay? So again, this Math Excel is due on Sunday night. I'll do the cell phone lotto for you in the last 10 or so minutes of yours if you want to start looking at that Math Excel. Circuit training this week is about quadratics. So maybe a nice, easy one to get an extra ticket starting out this new chapter.